Okay, so we are going to incorporate absolute value functions with our lines and our piecewise. So the important part about this is to make sure that if you're given an absolute value function, you identify the vertex first. So for this one, the vertex of this particular function is going to be -3, 0. So you need to determine if that vertex is included in your domain. So since it's at -3, which is over here, 1, 2, 3, -3, 0, and we're looking at x values that are less than or equal to 0, that is included. So we're going to graph that point first. Then we're going to graph this point, so what we get when x is 0. So if you plug in 0, you get the absolute value of 3, which is 3. So 0, 3 is this point right here. And this is going to be a closed point because it says x is less than or equal to. So if this is the vertex, the rest of the graph has to be symmetric over here. So you can do one of two things. You can either reflect this point over here. So for example, if this is the vertex, this is like up 3 and over 3 away, so you would go up 3 and to the left 3. Or you can just finish this part of the v with the slope of the absolute value function. So the slope would be 1, you'd go up 1 to the right and up 1 to the left. So our v looks like this. So it's not going to go past this point, okay, but it is going to continue forever that way. Use a ruler. Okay, and then for the second part of the function, this is just a line. So the line, x plus 1. Plug in your 0, and you get 1, which means we want to graph the point 0, 1. This time, it's going to be an open circle. Then you want to plug in something that's greater than 0, so 1. Okay, when you plug in 1, you get 2. So you have another point at 1, 2. And so that would be the second piece of the function. So the important part is you have to know where the vertex is so that you know if you're looking at the whole v. If the vertex was over here, then you wouldn't see the whole v. You would just see like the tail end of it. So you always want to find the vertex first and see if it's in the domain of the piecewise function. So for example 2, we have 2 times the absolute value of x. So this vertex is at 0, 0 because there's no k and there's no h. So that would be right here. But our domain is that we only want to graph that function for x values less than -2. So the vertex, which is over here, isn't going to be in our domain because we only want to graph that function basically to the left of that line. So that point's not going to be there, which means we're not going to see the whole v. We're only going to see like this part of it. Okay, so what we should do, since the vertex isn't in there, is we should take this point and plug it in. So g of -2. And be careful because this is absolute value. So you'd have 2, you'd have to take the absolute value of this, which is 2, and then you'd get 4. So that means we have a point at -2, 4. That's our first point, and it'll be an open point. So that point is going to be right 1, 2, 3, 4, right here. Okay. Then we would plug in another point, something that's less than -2. So something less than -2 would be -3. So this absolute value, this would be 3. 3 times 2 is 6. So you have a point at -3, 6. And so even though it's an absolute value function, you can't really see the whole thing. You can only see part of it. So it looks like a line. All right, then for the other piece, we're going to just do what we usually do. We'll plug in -2 to see where the first point is. When we plug in -2, we get -1 plus 3, which is 2. So I have a closed point at -2, 2. Then I want to plug in something greater than -2. I'm going to pick 0. 1/2 times 0 is nothing, plus 3 is 3, so you have a point at 0, 3, which makes our line. Okay, so go ahead and pause the video, do the retry, and then I will go over it when you unpause. Okay, time to go over the retry. So for this first one, the vertex is going to be at 0, 1, which is actually less than 1, so it will be included. So we're going to graph that 0, 1. Now remember, the rest of the V will look kind of either, well, actually in this case it's upside down, so it'll look kind of like this a little bit. We only want it up to 1, so 1 is right here. So we also need to plug in 1 and see where that point is. So if we plug in 1, we get 3 times the absolute value of 1, which is -3, and then we add 1, and we get -2. So we have a point at 1, -2. So 1, -1, 2. This point should be closed. So this is 1/2 of the V, and you can just easily reflect this over here to get the other half of the V. The other half of the V is going to continue to the left because we're including all values that are smaller than 1. But over here it stops. Then the second piece of the piecewise function is a constant function. So you're just going to go up to 1, 2, 3, 4 in the y, and you're going to graph the constant function that's greater than 1. Okay. For example 4. So I think this one will be easiest if we just graph the 2 constant functions first. So this one and this one, and then we'll go back to the middle one. So first, we want to graph the constant 2 for values of x that are less than -1. So -1 is here. We want to graph the constant function 2 for all values smaller than -1. Then we got this guy. We want to graph -2, but for all values greater than 1. So this is 1, values greater. Okay, so those are the 2 ends. Now we need to figure out what's happening in the middle. So what's happening in between here? That is our absolute value function. So first, the vertex is at -2, -1, which falls outside of our, oh, actually, so we have a little typo here. Change this -3 to a -1. So this vertex falls outside of that. It would be right around 1, 2, it would be right around here, which means our absolute value function would do something like this. We're not going to see the V, we're just going to see part of it. We're just going to see this part. So in that case, we don't have to worry about the V, we're just going to see some sort of segment. So we should take -1 and plug it in. So when we plug in -1, this is 1, the absolute value of 1 is 1. 1 minus 1 is 0, so we get -1, 0 as the leftmost point. So this point right there. And then we also want to plug in 1. Okay, so 1 plus 2 is 3, absolute value of 3 is 3, 3 minus 2, or 3 minus 1 is 2, So we have a point at 1, 2. It's going to be a closed point again, so 1, 2. So this is our middle section. Like I said before, we don't see the V, we don't graph the vertex because the vertex is falling outside of the domain. So it just looks like a piece. All right, this is one of the not equal to ones. So remember, whichever one says not equal to, that's going to be the majority of the graph. It's just going to have a hole in it. And then this point is just going to be a point. So looking at the absolute value function, which is going to be the majority of the graph, the vertex is 0, -1. You want to make sure that that's not like the whole of the graph. The whole is at 1. We have 0, so that's fine. So 0, -1 is our vertex. Now, you want to see where the whole of the graph is, so plug in 1, and you get 0. So at 1, 0, you're going to graph an open point. Remember, this is the vertex, and the slope of the absolute value function is 1. So this is like, you know, up 1 over 1. We would also have a point at up 1 over 1 over here. And so our absolute value function would look like this. So it's going to keep going in both directions. It's just that we have this hole here. We're going to see where that hole, or we're going to see where this function kind of, if it fills in the hole or if it's just a point somewhere else. So the second part of our piecewise function is 2x, only when x is 1. So if we plug in 1, we get 2. So that's just one single point right here. So we have an absolute value v with this big hole in it right here at 1, 0, and then just a random point right there. All right, so pause the video, try the WeTry, and then I'll go over it when you're done. Okay, time for the WeTry. So we have an absolute value function first with vertex 0, -4. This does not fall in this interval. 0 is here, -1 is here. So the first piece of our piecewise function should only be happening over here. Our vertex is happening here, which means we're not going to see the v. We're just going to see like this part of it. So we can go ahead and plug in -1. This is going to be 1. 2 times 1 is 2, -4 is -2. So we have a point at -1, -2, and it will be open. So -1, -2, open. Now if you want, if you paid attention to where the vertex is, you could, sorry, my point was at -3, so I moved it. I was going to say, if you pay attention to where the vertex is, you know that the slope of your v is 2, so you could actually just go up 2 and to the left 1 to graph the rest of this piece, okay? Or you could plug in another point less than -1, like -2, to get another point, and so that would give you 0, so you could also do that. Okay, so we're not going to see any of this. All right, so then the middle piece is a constant. So we're going to graph the constant function 5, which is right around here, for values between -1 and 2. So -1, 5 would be here. And we're going to go all the way up to 2, but we're not including 2. That's our middle piece. Okay, and then our third piece is just a line. So we want to plug in 2, and we get -3. So you're going to graph the closed point 2, -3. So 2, -1, 2, 3. Then you want to pick another point that is greater than 2, so maybe 3, and plug that in. I just realized I'm using F. Just kidding. Okay, so if you pick 3, you get -6 plus 1, which is -5. So 3, -5 is here. That's the last piece. Okay, so then the last two are you tries, so try those on your own, and then I will go over them. Try to do it by yourself and not with a partner. All right. The vertex of the first absolute value function is 0, 0, which is kind of included. It's on the graph, but it's open. It's an open circle. So open circle. If this is the vertex, then we can just use the slope of the absolute value function. It's going to go up 1 and to the right and up 1 and to the left. Since we only want values less than 0, we're just going to go up and to the left and not up and to the right. If you want, you can also plug in a value that is less than 0. So if you plug in -1, you get 1, and that's also how you can get that point. In the middle, we have a line. So to graph the segment that's going to be in the middle, I would just plug in 0 and plug in 4, and then see where that puts you. So if you plug in 0, you get 3, so 0, 3. And if you plug in 4, you get -1, so 4, -1, not including. So that's the middle piece. And then finally, we have this absolute value, which is just like this one. So we know the vertex is over here, which means we're not going to see most of the graph. We're just going to see the tail end of it, right? Because it's going to be like this. So what we should do is plug in 4. And that gives us 4, 4. So right up here. And then you can plug in 5. Oops. To get 5, 5, which is right here. So you get, that's the tail end. So like in theory, if we connect these, it makes the V. Okay, next you try. So remember the piece that says not equal to, that's going to be the majority of the graph. So the majority of our graph is this absolute value function that has a vertex of -3, 0, which is over here. It's not the hole. The hole is at -2. We should plug that in and see where the hole is. And we get the absolute value of 1, which is 1. So -2, 1 is the hole, which is right here. So remember, this is the vertex, so we can finish the graph by using the slope, which again is just 1. So this is up 1 to the right, already done. Up 1 to the left will get us the V. Just make sure you don't go through the hole. And then we'll finish the rest. So f of x equals 2x, we want to plug in -2, and we get -4. So that means you're just going to have another point at -2, -4, which is right here. Ta-da! The end.